Hey everybody, this is MoBaller12 here to help quench that knowledge thirst. For this video, I'll be specifically talking about mass percents. I know it's a kind of a simple topic, but I think it's extremely important for you guys to have a solid understanding on this topic because it will be foundational for my next video, which is on empirical formulas. So, quick little heads up, again, Facebook fan page, link in the description box below. Show your love and support, like the fan page, tell your friends and family about it. Also, feel free to start posting your specific questions in regards to the new series. If you don't know what I'm talking about when I keep saying new series, check out my video. I'll put a link in the top right corner, and it's called Quickie Update, so you'll get a better understanding of what that is. So that's excuse me, that's pretty much it. So let's begin with our discussion about mass percents. Okay. So I'm going to go down. First I'm going to explain the mechanics of basically the formula, and then we'll figure out how to calculate these guys. I'm kind of going backwards, and then finally I'll explain what it means. Typically you start off with what mass percent is, and then go through the calculations. I'm going to go a little bit backwards because I think it will make more sense that way. So just a quick little heads up. Again, mass percents are specifically for elements in a molecule. Okay, so basically atoms in a molecule. So it's not, the mass percents are not defined for the molecule itself. For the whole molecule, you don't find a mass percent for H2O. Instead, you find mass percents for the hydrogen or mass percents for the oxygen. Okay, so that's something you need to understand. It's for individual components of a molecule. It's not for the overall molecule. And so the general formula you need to understand is that the mass percent of, say, a given atom in a molecule, so mass percent of X, is going to be equal to A times the molar mass of X divided by the molar mass of the molecule. So I'm just generalizing it XY with these subscripts A and B. Okay, again, these subscripts refer to the amount of that specific atom you have in the molecule, and times it by 100 because we're dealing with percentages. Okay. So again, the A here is a subscript you find from the molecule. So if we're dealing with, say we're trying to figure out the mass percent of H2O, excuse me, not H2O, the mass percent of hydrogen, okay, the A in that case will be the 2. So you guys should be able to see it. So if we're trying to figure out the mass percent of Y, for example, this A will be replaced by a B, which is a subscript referring to Y. Okay, so that's what you need to understand. And again, the molar mass of that specific element or atom, it will be easy. You can spot that on the periodic table. And the molar mass of the molecule or whatever it may be is pretty straightforward. And it's a very simple way of calculating that, and we can go over that in a little bit when we go through an example. So here I have two examples, and we're going to implement this formula that I have up top here to figure out the mass percents of every single atom in each one of these examples. Okay, so let's start off with H2O. Let's find the mass percent of hydrogen in water. Okay, so for example, we're going to just basically plug in things into this formula. So A in this case, since we're talking about H, so we're going to look for, let's put this, so mass percent of H, that's what we're looking for, is equal to, so mass percent of H, let me zoom in just a tad bit so you guys can see. So the mass percent of H is equal to A, which is a subscript referring to the hydrogen, so it's 2, times the molar mass of hydrogen, and that's found on the periodic table. Let's see if I have my periodic table handy. I do. The molar mass of hydrogen, if you guys can see, it's 1.008 grams per mole. Make sure you have your units. It doesn't really matter because at the end we're dealing with a percent and everything will cancel out. Percentages don't have units. Divided by the molar mass of water, and that's pretty straightforward. You guys should know how to calculate that out. Molar mass of water, okay, hydrogen weighs 1.008, and that's from the periodic table, and times it by 2 because that's how many hydrogens we have. And oxygen is 16.0 approximately, and these units are all grams per mole, and we add these, we multiply this out, add the two together, that comes out to 18 I already did the calculation, so 18.016, okay, grams per mole. That's the molar mass of water. So 18.016 grams per mole, and as you guys can see, the grams per mole and the grams per mole cancel out. Excuse me. And then all we have to do is crank this out on our calculator, multiply it by 100. Don't forget, once you plug all this stuff into our calculator, the answer I got, double check this with, do this on your calculator as well. The answer I got for water, it was specifically for the atom hydrogen, is 11.19%. 11.19%. And I'll talk about what this means, okay? And just zoom out just a tad bit. Put that there so we could separate that. Now we're going to apply the same thing for oxygen. Again, this is a very simple calculation. Mass percent of oxygen is going to be equal to, in this case, for oxygen, the subscript is 1, so we don't even need to put there, because 1 times whatever it is, it's going to be that value. So we'll just do it just so you guys can see the formula in effect. The molar mass of oxygen is 16.00 grams per mole. It's an approximation. Again, the molar mass of water is 18.016 grams per mole, and times that by 100, and I calculated that out to be 88.81%. 88.81%. Okay, so we figure out the mass percent of oxygen is 88.81% in water, and the mass percent of hydrogen in water is going to be 11.19%. So basically, for a given molecule, these percentages never change. Okay, so if we're dealing with water, the mass percent of oxygen is always going to be 88.81%, and the mass percent of hydrogen is always going to be 11.19%. Now, that doesn't really tell you anything. At this point, you guys may be wondering, what is this guy talking about? He keeps saying mass percent, but what does that mean? What do these numbers mean? I'll get to that in a second. I just want to make sure you guys understand the mechanics, how to plug this into the calculator, how to use that formula, okay? So, again, I'll talk about I'll give you guys an example of how to understand what mass percent is, but just understand that that's how you calculate it. Okay, so we figure out the mass percent of each atom in water. Okay, so let's apply the same thing for methane. Okay, CH4 is methane. First things first, let's get the molar mass of methane out of the way, what we did for water. So methane's molar so the molar mass of carbon is 12.01 grams per mole. Molar mass of hydrogen is 1.008 grams per mole. We have 4 of them, so times that by 4. Get the sum of these guys. Okay, I get a value that is 16.042, and just double check that on your guys' calculator. Okay, and it's grams per mole. Okay, so again, I got a value 16.042 grams per mole, and again, double check that on your guys' calculator. Let me just clean that up a little bit. Grams per mole. Okay, so again, we're going to apply the same formula to determining the mass percent of carbon and hydrogen in this methane molecule. So the mass percent of, let's start off with carbon, of carbon is equal to the subscript of carbon is going to be a 1. And when you don't see a subscript there, you always assume that there is a 1. Okay, so in this case it will be 1 times 12.01 12.01 grams per mole over the molar mass, right? The formula is the molar mass of the molecule. In that case, it's going to be 16.042 grams per mole times it by 100, and I get a value, already calculated this out, 74.86% about. Your guys' values may be a little bit different. depending on how many decimal places, how many numbers after the decimal place that you guys use in your calculation. It might be more accurate. So if you use more places after that decimal, more numbers after that decimal, your number will be more accurate. And then the mass percent of H is going to be, the subscript in this case for hydrogen is 4, so it'll be 4 times it by the molar mass of hydrogen, which is 1.008. Let me make sure that's, even though the units cancel out and we can just forget about the units, it's good to get into that habit, because eventually it could haunt you if you don't keep track of your units. So the molar mass of methane again is 16.042 grams per mole, times it by 100, and I get an answer that is, crank this out on your calculator, I get an answer that is 25.14%, and that's specifically for hydrogen. Okay, so again, mass percents are for specific atoms in a given molecule. Okay, so the mass percent of carbon in methane is always going to be 74.86%, and the mass percent of hydrogen is always going to be 25.14% in methane. As you can clearly see, these values, this mass percent of H is completely different than the mass percent of H in the top case. So that's just basically, solidifying the fact that mass percents of a given atom is going to be different if the molecules are different as well. Okay, and clearly we see that. So again, it's not that difficult to understand as far as the calculations of how to crank this out on your calculator. But again, the goal of my channel is to explain what it means, understanding what it means. It's not about just cranking it in your calculator. So now that we understand the mechanics and how to go through plugging this into that formula and cranking this out on our calculator, now we're going to look at what does this all mean. So let's erase all this, the bottom half, because I need some space, and I'll be working with the values I got for water. Okay, so hopefully you guys copied this all down, or whatever you guys did, because I'm erasing this, so it's gone forever. So the way we can understand this is through this example. Okay, so again, the values that we determined was 11.19% and 88.81%. Okay, so now we're going to understand what this all means. Let's translate this all into some layman's term, where we could really have a solid understanding about what mass percent really is. So let's just assume we have a beaker. Let's see how good my drawing is today. Let me see how well on point my drawing is. Your beaker usually has those little marks there to represent 50 mils, 100 mils, 150, 200, whatever it may be. Okay, so we have our nice little beaker, and it has some water in it. And let's just say, for example, way out, we put some water into a beaker, we go to our weighing station and we weigh it out, again in units of grams typically, or whatever unit you may use, but let's just say grams because it's an easy unit to work with. And this is again water, and let's just say we weigh it out, just specifically the water itself, and the water itself weighs 100 grams. Okay, 100 grams of water. We have to do a little bit of mathematics to subtract. The mass of the beaker itself, so we get an exact value of 100 grams of water. But nonetheless, let's not get sidetracked. Let's just assume that it's 100 grams of water, and let's just assume that the beaker is essentially weightless. Okay, it has no weight, has no mass. Okay, so it'll be 100 grams of water. So basically, what these percentages are telling you is, if you have 100 grams of water, 11.19% of that total mass is due to the mass of hydrogen present in that 100 gram sample. It's also saying that in this 100 grams of water, 88.81% of that total mass is due to the mass of oxygen. So for example, if we wanted to figure out what is the mass of, we have the percentages of hydrogen, the mass percent of hydrogen. So if we have a sample of 100 grams of water and 11.19% of this total mass is due to hydrogen, then what is the mass of hydrogen present in this 100 gram sample? Well, it's easy. What is 11.19% of 100? It's 11.19. So in this 100 gram sample of water, 11.19 grams of it is due to H. And we could do the same thing for oxygen. And oxygen, the mass percent of it is 88.81%. So what that's telling you is that in this 100 gram sample of water, 88.81% of that 100 grams is due to oxygen, the mass of oxygen. So what is 88.81% of oxygen? Excuse me, what is 88.81% of 100 grams? It's 88.81 grams of oxygen. So obviously the sum of these two will equal 100 grams. And now we could constantly apply that. It doesn't have to necessarily be 100 grams of water. We could apply, we could apply it to 500 pounds. We could apply the same reasoning, the same thinking to 10,000 pounds, 10 million pounds, 10,000 grams, 10,000 kilograms. Okay? And we get a certain value. Obviously, we understand that this mass is due to the composition of the water molecules, right? And how we can determine the specific, how we can determine how each one of these specific atoms are contributing to the total mass is by understanding what the mass percents are. So we could apply the same reasoning and same thinking. Let's flip this up a little bit. Let's just say we have a 1,000 gram sample of water. And let's just say, well, what is the mass of oxygen and hydrogen present in this 1,000 gram sample? Now we know the mass percents, and if we know those guys, it will make our life extremely simple. So what is 11.19% of 1,000? Well, 11.19% of 1,000 is 119. 111.9, excuse me, grams of H. And if we do the same thing for oxygen, it will be 888.1 grams of oxygen. Okay? So basically, again, depending on the sample size, these numbers that you calculate out due to the percentages is going to adjust. So the percentages never changed, but the mass of the specific atoms will change due to the sample size. So if we're dealing with a bigger sample, well, obviously you're going to have to compensate for that. If you're dealing with a smaller sample, obviously you'll have to compensate for that. So that's essentially it. That's how you can look at mass percents. And that pretty much concludes my discussion on mass percents. I hope this all made sense. This is extremely important when we talk about empirical formulas and eventually molecular formulas, and that's the direction we'll be heading. So thank you guys for watching. And this is Mobile 12 signing out.